Today we're going to look at the quadratic formula, but first I want to give you an idea of where it came from. Now this is going to be some fairly abstract algebra that we're doing here, some symbolic work, so just hang in there as we work through it, just see if you can follow along with how the process would work. So this time, instead of using numbers, I'm going to use a, b, and c. And if I'm going to complete the square, it means I'm going to factor out this a. So this is what I'd have left over. And then to complete the square, I would divide this by 2, so I would get b over 2a, and then I have to square it. So I'd have b squared over 4a squared. Now, because I've added that, I need to balance out my equation. So I have to subtract a times b squared over 4a squared. So I'm going to complete the square now on this. And as a perfect square, it's going to be this value here that we used when we divided it in half. So I'm going to have x plus b over 2a squared. And there's an a on the top here and 2 on the bottom. So I could rewrite like this as well. And I know that takes a deep breath to get from where we started to there. But again, if we were just to work through procedurally what we do when we complete in the square, this is what we did, but now we're using the letters a, b, and c. So now I'm going to solve this equation. So what I have here is I'm going to move everybody to one side, like we would have otherwise. It's going to be equal to b squared over 4a minus c. And then I need to divide everybody by a, so I'm going to have x plus b over 2a, all squared, is equal to b squared over 4a squared minus c over a. Now I'll also make a common denominator here. So if I make a common denominator, I have to multiply by 4a on the top and the bottom. And now I'm ready to take the square root of both sides. So I'll continue my work up here. So this would give me x plus b over 2a is equal to the square root of b squared minus 4ac. And it's all divided by 4a squared. I can also simplify this a little bit further. I can make this the square root of b squared minus 4ac over the square root of 4a squared. And this is already a perfect square. This is like 2a all squared. So I can rewrite this one final time here as b squared minus 4ac. And the whole thing is going to be divided by 2a. So all that's left then for me to do is solve for x. So I'm going to move this term to the other side. So x is equal to negative b over 2a plus root b squared minus 4ac over 2a. And I already have a common denominator, so I'm going to put those fractions together. Now I know it's overwhelming, so it's a little easy sometimes to lose sight of what we did. But remember, when we did this part, we're supposed to take the positive and negative value because we could use either since we're squaring it after. So this here should not just be a plus, it should be a plus minus. So another reminder to you just to make sure that when you're doing your work, you need to have the plus and minus part in here as well. So this in fact is the quadratic formula. If you want to know the solutions to a quadratic equation, and this is the form that you've been given to it, here's the quadratic formula to finding those solutions. It might not quite look like the easiest formula to use, but it means we don't need to do the process of completing the square, because solving it the way we did, it just used the process for us. It's basically a shortcut that gets us from the equation right to the answers without having to complete the square. So if you're going to use this formula, first you should know the way that it works. So I'm going to rearrange the formula. There's nothing wrong with the way it is now, but students tend to think that this is A, B, and C, the first three that they see. That's not the way it works. A is always the number in front of x squared, B is always the number in front of x, and C is the constant. So in my problem, it's like this. So if you were to rearrange this as negative 2x squared plus 5x minus 3, it might be easier for you to see that this is A, B, and C now that you've got it in the proper order. So A is equal to negative 2, B is equal to 5, and C is negative 3. Now again, when we're working with it, it has to be in the standard form. This is not in the standard form, and it's not equal to 0, it's equal to 17. So if I move everybody to one side, I'll have 3x squared minus 2x minus 12 equals to 0. And now I can see that A is 3, B is negative 2, and C is negative 12. And again, looking at this one, I'm not sure that anyone would do that, but A, B, and C you might be tempted to think, but remember it has to be in standard form where everything is equal to 0. So I could go negative 2x squared, move the 8 over would be negative 3x, and move the 10 over would be positive 8 equals to 0. So here A is equal to negative 2, B is negative 3, and C is equal to 8. Now some people have wondered, well, what if I rearrange it on the other side? What if I got 0 equals 3x squared plus 3x minus, sorry, that should be a 2x squared, and then it would be minus 8. Well, if you use these values, it's still going to give you the same answer. So it's still going to give you the same answer. If you compare these two equations, one is the negative of the other. So here where it's negative 2, I get positive 2. Here where it's negative 3, I get positive 3. And here where it's positive 8, I get negative 8. So if I was to paint a picture for you for really what's happened, if we saw the solutions graphically like this, and then I moved everybody to the other side, I would get the same solutions, but it would just be that I flipped it because there's a negative that's been introduced. So you're going to have the same solutions even though you have different equations. Okay, so let's try solving using the quadratic formula. In this case, I have my A, B, and C values. So it's going to be negative B plus or minus the square root of B squared minus 4AC. And everybody's divided by 2A. So this is going to be negative 5 plus or minus the square root of 25 plus 24 all over 6. So that's negative 5 plus or minus root 49 over 6. So negative 5 plus or minus 7 over 6. So I have two possibilities, one which is negative 12 over 6, another which is 2 over 6. So 1/3 is a solution, as well as negative 2. So again here, I have A, B, and C. I can fill them in as negative B plus or minus the square root. So B squared is going to be 25 minus 4AC. And we're going to divide this by 2A. So 5 plus or minus square root of 25 plus 72. Sorry, that should be 96. Tried to do it in my head a little too quick. And it's all over 4. So this will be 5 plus or minus square root of 121 over 4. So 5 plus or minus 11 over 4. And I could write that as two possible solutions. 5 minus 11 is negative 6 over 4. And 5 plus 11 would be 16 over 4. So this would give me 4 and negative 2/3. Okay, so to simplify radicals, we're going to be working on problems where you're expected to put your answer in simplest form. And the way this is going to work is you want to think about where are the perfect squares. So let's write those down. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. We can keep going. Make a bit of a list to refer to. And so on. But that's most of the ones that we're going to be looking for here. And what we want to do is find the largest perfect square that we can divide out. So I could write root 50 as 2 times 25. So 25 then is one of the factors, which means I can take it outside of the square root, but when it's outside, it's only worth 5. 192 can be rewritten as 3 times 64. So 64 inside the square root is going to be worth 8 when I take it out. And similarly with 80, if I look for the biggest perfect square in there, that'll be 16 times 5. So 16 inside the square root can be taken out and be 4 root 5. So this is more like the way we're going to see it in a quadratic equation. You're going to have values like this, and we're going to be able to simplify out if we are able to do this with radicals. So for example here, I could write this as 20 minus the square root of 3 times 16, all divided by 4. That's 20 minus, if I take that out, I'm going to have 4 root 3, all divided by 4. So everybody can be divided by 4 in this case. 20 divided by 4 and 4 root 3 divided by 4. So I would end up with 5 minus root 3 here. It's equivalent, and it's a much simpler form than where we started. In the next example, we could do the same thing. I could rewrite this as negative 15 minus the square root of 5 times 81, all over 6. And 81 comes out as a 9 when I move it to the front. So this will be negative 15 minus 9 root 5 divided by 6. And this time I can't quite remove the fraction. I'm still going to have a fraction here, but the greatest common factor is a 3. They all share a 3. So I could think about this as negative 5 times 3 minus 3 times 3 over 3 times 2. And since everyone has 3 as a factor, this would be negative 5 minus 3 root 5 over 2. So now when we solve these in quadratic equations, we're going to try to write them in simplest radical form, and then we'll get our calculator to show us what the values would be as well. So A, B, and C in here are going to give me negative b plus or minus b squared minus 4ac all over 2a. So this will be 3 plus or minus 9 plus 8 all over 2. And I cannot simplify this anymore. No one shares any common factors, and I can't pull out any perfect squares. So that's in simplest radical form. And now we want to put it in the calculator and get it to 2 decimal places. So one possible solution would be 3.56, and the other one would negative 0.56. So it is a bit of a skill putting it in your calculator properly, depending on where you put the brackets and whatnot. So you do want to practice that. We'll try again here with a, b, and c. So negative b would be 2 plus or minus the square root of b squared is 4 minus 4ac all over 2a. So this will be 2 plus or minus the square root of 4 plus 4 all divided by 2. So 2 plus or minus root 8 over 2. And I could write that as 2 times 4. And I'm going to remove 4 as the perfect square. So 2 plus or minus 2 root 2 over 2. I can see that everyone shares a common factor of 2. So that's in simplest form 1 plus or minus root 2, and then we can use the calculator to get that to 2 decimal places. So first of all, we'd have 2.41, and we'd have negative 0.41. Okay, so these numbers are getting a little larger. It'd be tricky to factor these. So it's good that we have another technique here. So negative b will be negative 12, and plus or minus square root b squared minus 4a and c all over 2a. So I'm going to get the calculator to give me what the value is inside, and it is quite large. So we have negative 12 plus or minus square root of 8,784. Now, even though it is quite large, again, we're still just looking for very big perfect squares that it can divide into. So one thing that you may want to try here is you've got this, it looks like I have a common factor of 6 here, so maybe I'll try 36 as a perfect square. So what I've got in my calculator right now is 8784 divided by 36, and it gave me 244. So it definitely is one of the perfect squares, but I'm not finished here because I may have more that I'm looking for. So for example, I could divide 244 by 4, and I get 61. And at this point, I can't go any further. So I can see these factors, 36 and 4, are perfect squares. So 36 times 4, that's going to be 144. And what's left over is the 61 here. So I'm going to have negative 12 plus or minus root 144 times 61 all over 18. So 144, when I take that out, it's going to be worth 12. And there's a greatest common factor amongst these of 6. So if I divide 6 out of everyone, I'd have negative 2, negative 2 plus or minus 2 root 61 over 3. So I can't simplify this anymore. That is in simplest radical form. And I'm going to calculate it to 2 decimal places. So one solution I get is 4.54. The other one I'm getting here is negative 5.87. Now, we're going to try solving this next one here, just to illustrate a point. So, negative b would be negative 1 in this case, plus or minus the square root of 1 squared minus 4 times 1 times 1, all divided by 2a. So negative 1 plus or minus the square root. it's going to be negative 3 in here. So we've run into a problem now with the quadratic formula. And the problem here is that this being negative means that there's no real solutions. These would be complex numbers or imaginary numbers that we would use since we're taking the square root of a negative. So in here, there's actually no solution. And that shouldn't surprise you because we have talked about the various graphs and how that could look. For example, that graph might look like this, and it just never touches the x-axis. So it's important when you use the quadratic formula that you know how that is made in the connection. And things can only go wrong here in that square root. So we have a special name for the value under the square root, that b squared minus 4ac. We call it the discriminant. So when we have two solutions, that means b squared minus 4ac has to be a positive number. It has to be positive in order for me to take the square root, and it has to be positive so that that way I get some number out and I have to add and subtract it. So I'll get one solution when I add it and one solution when I subtract it. If I want there to be one solution, what I have to do is get rid of that plus and minus action, and the only way I can do that is by adding 0. So if b squared minus 4ac is equal to 0, then adding and subtracting 0 just gives me the same single solution. And if there's no solution like we just saw here, b squared minus 4ac must be less than 0. There's another thing that can be very helpful with the discriminant, and that's if you want to know can something be factored or not, then what we're going to do is we're going to just take a look, is the discriminant a perfect square? Because if it's a perfect square, then this will be gone, and the solutions I get are going to be rational numbers, which means I should be able to factor the equation. So that's one way it can help you decide amongst the techniques you have. Factoring is generally the fastest way. If you get b squared minus 4ac and it tells you it's a perfect square, try factoring. If not, it'll still give you some insight into what the problem, maybe there's 0 solutions, maybe there's 2 solutions, maybe you know there's no solutions. You may actually have solved the problem just by doing this little bit of work at the beginning to find the discriminant. So let's try this here. In this example, b squared minus 4ac is going to be 9 minus 4 times 1 times 1. So 9 minus 4, which is 5. So since that's positive, there's going to be 2 solutions. However, it's not a perfect square, so we won't get nice factors, or ones that are rational anyways. In this case, b squared minus 4ac is going to be negative 24 squared minus 4 times 48 times 3, and I get 0. So I know that when I do the quadratic formula, I won't be doing plus or minus, that's gone, so I'm only going to have one solution here. And 0 in fact is a perfect square. 0 squared is 0, so this will factor. And because we have one solution, remember the graph's going to look like this. It's going to come down and just skim one point, and those are generally the kinds that go like this. You know, x plus 1 squared equals 0. So you're actually going to have a perfect square when you're done. In this particular instance, you're going to have 9 minus 4 times 2 times 1. So 9 minus 8, which is 1. That's greater than 0, so I'm going to have 2 solutions. And 1 is a perfect square, so it will factor. And it'll factor nicely. So you might not be sure by looking at it, but that tells you it's worth your time. If you try factoring it, you should be able to. Other numbers that we'd be looking for, of course, anything from that list that we were just talking about. Okay, so in the last one, remember it always has to be in standard form. So really what we're dealing with here is 4x squared plus 2x plus 8 being equal to 0. So b squared is 4 minus 4 times ac So that's going to be 4 minus 128, which is negative 124. And that's less than 0, so there'll be no solution here. And I suppose we should put no real solution. Again, this would require complex numbers in order to solve, so it's not something that we'll be looking at. We'll call this no solution.